The quiz is on Wednesday. It's 1-7 to 110. Okay. Yep, so on Monday we'll do 110. Tuesday we'll review Wednesday quiz. Yep. All right, so this is in 1-8 and 1-9. We talk about the zeros of rational functions. We talk about vertical asymptotes, and we talk about slant asymptotes. Which question 4 on your AP questions yesterday had a slant asymptote, which is what they asked about, which is why I said to wait on it, okay? So we'll go back to that question when we're done. So the zeros of a rational function are where it crosses your x-axis, right? So we just set the numerator equal to 0. Technically, we are finding the x-intercepts, which means we plug 0 in for y. And you don't need to write this out, but just think about what happens when I have this and it says like x squared plus 2x plus 3 over x plus 5. Let's say I had, wait for it, something like this. All right, so if I had asked you to find the 0, which is the same thing as finding the y-intercept here, we would have replaced this f of x with 0, and then what would be your first step? Multiply the denominator out, right? Get rid of that. And every single time we end up on the other side multiplying our denominator by 0, which means what happens? It literally goes away, becomes 0, which is why we simply ignore the denominator when we find the zeros. We just set our numerator equal to 0, okay? So we skip that step entirely. We are doing it technically, but we skip it. So it's no different than finding any other zeros or any other y-intercepts. It's just that we know that first step is going to be canceling out the denominator, so why even bother, okay? So before we get to this step, we will factor and see if anything cancels out. So when we're going through rational functions, I said it yesterday, but I'll remind you. Step 1, if it asks for domain, step 1 is find domain. So we find domain before we do anything else. Step 2, see if your function can simplify. Step 3 could be something like find zeros. So, and then go into vertical asymptotes. So vertical asymptotes are those vertical lines that cause your graph to start and stop as it moves from left to right, okay? They have vertical asymptotes where the denominator would equal 0. So the same way we restrict domain, we say that it can't equal that number. If it equals that number, that's where your vertical asymptotes are. So to find these, we're going to set the denominator equal to 0. So zeros come from my numerator, vertical asymptotes come from my denominators. They are vertical lines, so that has to be in the format of x equals. You cannot just give me the number. It has to say x equals. And again, we would do this after we simplify. So if we're going all the way through, first thing is domain, second thing is simplify, and then you can do your zeros, your vertical asymptotes in any order. But this would come after we simplify. All right, example 1. Find the domain, the zeros, and the vertical asymptotes of the rational function. So for A, we're going to go in the order specifically of doing domain first. So I set my denominator not equal to 0. I get x cannot equal 5. So my domain is negative infinity to 5 and 5 to positive infinity. Domain comes first. Then I would look to see if this can be simplified. If I can factor the top or the bottom or cancel anything out, that's what I'd be looking for here. It's not happening this time. So then I go to the next thing. And again, order after this doesn't really matter. But vertical asymptotes are just the opposite of what we found for domain. So the domain is restricted by not equaling 5. Our vertical asymptote is that it would be equal to 5. So just change the sign on the last thing. And then for the zeros, we set our numerator equal to 0, and I would get x equals negative 4. So my 0, and there's only one of them, is negative 4. And the zeros we list. So we did domain, we did zeros, and we did vertical asymptotes. It didn't ask for it, but what would have been your horizontal asymptote? 1, y equals 1, right? This is the scenario and the exponents are the same, so this would be your leading coefficient. All right, go to B. First, start with your domain. So you can factor at the beginning, like I can factor top and bottom if I want that to be the first step, because I'm going to have to eventually do that anyways. So factors of -5 that sum to -4 would be -5 and +1. But before I cancel anything out, if it can cancel, I'm going to do my domain. So I set the denominator is not equal to 0, and I get x cannot equal 5, and x cannot equal -1. So my domain goes from -infinity to -1, -1 to 5, and 5 to +infinity. Then before I find my zeros or my horizontal asymptote or my vertical asymptotes, I look to see if I could cancel something from the top and the bottom. Can I? No, so I'm not canceling anything out. That creates a hole, and that's what we'll do next section. But you do need to know that that could happen. So then I want to find my zeros. I'll go vertical asymptotes. Instead of saying not equals here, I change this to equals. So my vertical asymptotes are at x equals 5, or change these, and x equals -1. They need to be separated out because those are two separate lines. Yep.
How do you know which one to find the zeros for?
Zeros are numerator.
The vertical.
Vertical asymptotes are denominator.
Okay, we don't know. Wait. Oh, okay.
Yeah. Okay, then zeros, I set my numerator equal to 0, and I already factored it, but if I didn't already factor it, I would factor it at that point. And I get x equals -2 and +2, these we list. Good so far? Yeah. Good question. So horizontal asymptote, x is raised to the second power in the first and the top and the bottom, right? So this is your leading coefficient scenario. That would be 1/1. So horizontal asymptote would be y equals 1.
So we don't pay attention to the 4x?
Say again?
We don't multiply the x's in the bottom?
No, so you want to go back. So horizontal asymptote, I want to go back to the original. As long as I haven't canceled anything out. If I canceled something out, then I have to go after it's been canceled out. But we'll worry about that when we get to holes. Yeah. Okay, so C. Again, see if you can factor. In the numerator, I can take out an x because I'm going to have to do it eventually anyways. Can I factor the bottom? No. So I say domain. First, set my denominator not equal to 0. I get x squared cannot equal -5. And I get x cannot equal plus and minus the square root of -5. Is that a real number? No, I can't have an imaginary number on my graph, which means I can't have an imaginary number on a vertical asymptote. So I literally say there is no restriction here. And my domain would be all real numbers, -infinity to +infinity. So because there's no domain restriction, well, first of all, go and see if you could cancel anything out. You can't cancel anything out, so I'm going straight off of what's already there. Since there is no domain restriction, that means there's no vertical asymptotes. I can go left to right on my graph. It would have occurred at x equals plus and minus 5i, which does not exist on a graph. Then for the zeros, you set your numerator equal to 0. We're going to split and solve here, and I get 2 zeros, 1 at 0 and 1 at 4. What would have been your horizontal asymptote? Y equals 1. Questions on that one? All right, now look at the graph. Okay, so you're going to get times in which you obviously have an equation. You have to understand what you're looking at, and then there's going to be times in which you're looking at a graph. These graphs are not always going to have those lines drawn in, so you have to figure out where they would go. There would have been a vertical line here. I know that because my graph splits there. And there would have been a vertical line here, and I also know that because my graph splits there. Then remember the end behavior, so the outsides are affected by a horizontal asymptote. So that means there's also a horizontal asymptote through 0. And you will not always, sometimes they give it to you with the lines, but sometimes they don't. You got to know what you're looking at, okay? So let's talk domain first. Domain, we go left to right. So what's the furthest point left? Negative infinity. Does it stop? At -5. Does it pick back up again? From -5 to 2. Stops again. Picks back up again at 2. Good. Goes to positive infinity. Yeah. Yeah, so horizontal affects the edges, not necessarily the middle. Okay? It is impossible for it to cross through your vertical asymptote, but it is possible for it to cross through a horizontal asymptote. So horizontal asymptote is kind of like the guide that affects the edges, but it does not mean it's undefined there. So let's think, it didn't ask about it, but talk about range here. What's true about your range? Does it stop and start? On the outside, yeah, but on the inside, it's literally going through that whole thing. So the range here would be all real numbers. Does that make sense? Okay. All right, so now zeros, or let's say vertical asymptotes. Where are my vertical asymptotes? X equals -5 and X equals 2. And where are the zeros? How do I see a zero from a graph? Where it crosses the x-axis or my x-intercept, there's only one at -2. Where the zeros are the x-intercepts.
Oh, and you put the numerator equal to 0?
Yep. Because I wrote it wrong. It should be -5. Thank you very much. Any other questions? Okay. Now let's talk about what it affects as far as limit notation goes. So just like that stuff was algebra 2, if you remember it, okay? Now we get into the limit notation part of it. So we have to think about how would I describe the behavior of this graph in limit notation. So just like with your horizontal asymptotes, you're talking about here's what I want to look at where the y values are, the x values are, what is happening to my graph, the y values. Now the difference is we're not describing end behavior. So our end behavior, our x values went to positive infinity and negative infinity here, right? But we're not talking about end behavior. We're actually talking about what happens around my vertical asymptotes. So your bottom numbers, the x approaches numbers, are going to be where your asymptotes are, the x values of those asymptotes, okay? Then we're going to describe what happens to our arrows. Do they point up? That would be positive infinity. Do they point down? That would be negative infinity. Now notice that they have these little symbols on them now, a minus and a plus. That is because you can approach this vertical asymptote from the left and your graph might be doing one thing, or you can approach it from the right and your graph might be doing another thing. So those little symbols mean from the left and from the right. So if it's a minus, we're saying as it approaches negative infinity from the left, 5, sorry, and as it approaches -5 from the right.
Do we change the bottom number to 2? Because ours is 3.
Does it? Your vertical asymptote's at 2, right? Yes, change it to 3. So again, it's not there, but there's a vertical asymptote at -5, and there's a vertical asymptote at +3. Positive 2, that's why that should say 2, not 3. And now let's talk about the direction. So that first box that we're filling in says what the limit as x approaches -5 minus, which means as I'm coming from the left here, what's happening to my y values? They are decreasing without bound, which means they would equal negative infinity. The next part says the limit as x approaches -5 from the right. So now I'm coming from the right-hand side here. What's happening to my y values? They're increasing without bound, which means it's approaching infinity. The next one is the x approaches +2 from the left. So now I'm going this way. What's happening to those y values? Decreasing, so it's going to negative infinity. And, oh, this should be a +2. Wow, bang up job. That should be a +2. Thank you. Positive 2 from the left, and on the other side, positive 2 with a plus means positive 2 from the right. What's happening there? It's increasing without bound, so f of x would equal infinity. So this is describing your vertical asymptotes using limit notation. When we do get to limits, you'll find that if it's going to different points at the same, like if it didn't have the minus and the plus, we would say the limit does not exist, which is what Lindsay Lohan says, okay? But it is based on the direction as it's approaching, and that's why we have to have the plus and the minus, because those would be two different answers. Not always two different answers, but in this case, yes. All right, you try this. So actually write out your limit notation. The number on the bottom should be where your asymptotes are, and each one should have a plus and a minus. So you're looking for 4 limit notation here because there's 2 vertical asymptote. All right, so first thing you have to do is identify where your vertical asymptotes are. There's one at -5 and there's one at +4. So each one of them gets 2 limit notations, coming from the left and coming from the right. So as x is approaching -5 from the left, what's happening to my graph? It's going to positive infinity, increasing without bound, going to positive infinity. As the limit is, or as x approaches -5 from the right, what's happening to my y values? They're going to negative infinity because it decreases without bound. As the graph approaches 4 from the left, what happens to my graph? It's decreasing without bound, so it goes to negative infinity. And as it's approaching 4 from the right, increasing without bound, so positive infinity. Questions? So you need to know how to finish out the limit notation, but you also need to know how to write it from scratch. Because there's going to be times in which it would be multiple choice, but then it's also going to be times in which this could be a free response question. Okay, now let's do the table. So we did this a little bit yesterday, but let's talk about what happens when there's a vertical asymptote. It says complete the table, then find the horizontal asymptote using an equation and limit notation. So we're going to do it both ways. So I'm going to take my y equals, and I'm going to write in that full equation, x squared minus 5 over x plus 3. This time those values are small enough that would probably be on my screen. So if you wanted to try to just do your value button instead of doing your y1 and y1 and y1, you can just go to your second trace and you could go to value, type in -2.9. Oh, it gives it to you in a fraction, but you can always switch it to decimal. You get 34.1. I'm going to repeat it again with -2.99. And I get 394.01. I'm going to do it again, -2.99, 3,994.001. If I do it with -3, what happens? It says error. If you look at your error message, it says error. Your error usually tries to tell you what it is. Divide by 0. What does that mean? It means the denominator would be 0, and that makes sense because if I plug in a -3 into my equation, my denominator is going to be 0, which means it's undefined there, right? So either I have a vertical asymptote or a hole, which we'll get to, okay? But for right now, we're going to put undefined in there because there is no answer. And I'm going to keep going. So I go back, and I do y1. -3.001, and I get -4,006.001, -0.01, -406.01, and -3.1, and I get -46.1. All right, so what's tricky about this is that these values are actually smaller than these values, right? So our brain thinks left to right, which means like we tend to think as it's approaching 3 from this side, this would be smaller than as it's approaching, but it's the other way around here. -3 is where my vertical asymptote is. But these values are on this side of my graph, right? Because it's going from -3 to -3.01 to -3.001. So as those values, as it's coming from the left-hand side, these values are getting smaller. So it's going in this direction. I don't know where my horizontal asymptote is right now. It actually wouldn't exist in this one, but I'm not worried about it. I'm just worried about what that arrow is doing. And then these values are actually getting bigger. So as it's going towards that -3, these y values are getting bigger, which means it's going to positive infinity. So you can either look at your values or you can try to give yourself that visual. Just be careful. So the limit as x approaches -3, I need it from the left and I need it from the right. So as it's getting closer to -3 from the left are these values, which would be these values. It's approaching negative infinity so it's decreasing without bound, so it's approaching negative infinity. And then as the x values are approaching this should be -3 from the right, that's actually this side. My y values are getting bigger without bound, which means f of x equals positive infinity. Good job. Questions? So pay attention to the order of those numbers. Okay. All right, now let's talk slant asymptotes. So there are vertical asymptotes, there are horizontal asymptotes, and there are slant asymptotes. A slant asymptote occurs when the degree of the numerator is one more than the degree of the denominator. So it is a very specific scenario. If you remember yesterday, we said if the exponent in the top is bigger than the bottom, there's no horizontal asymptote, right? Which means a horizontal and a slant cannot coexist. You can have one or the other or neither, but you cannot have both. To find the equation of the slant asymptote, we divide the numerator by the denominator, and the quotient without the remainder is the equation of the slant asymptote. So you can divide by either using long division or synthetic division if the denominator is only x plus or minus, which we'll review both quickly, but you can divide using either. You can always use long division, but you can only use synthetic when you have x. Like if you're dividing by x plus or minus a number, this is when we can do synthetic. If our denominator had x squared in it, then we can't use synthetic. We have to use long division. Okay. But again, this scenario only happens if the numerator in the top is one more, or the degree in the top is one more than the degree in the bottom. All right, so example 4, find the slant asymptote. First of all, it will get looped in together and say identify all the asymptotes. So you'd have to look at this and know that there is a slant asymptote. Obviously, it's telling you in this question, but eventually they're going to loop together. The degree in the numerator is 2, the degree in the denominator is 1. That means it is one more than the bottom. That's when a slant occurs, okay? Because the bottom is just x plus or minus something, we can use synthetic division here. So if you remember synthetic division, you change the sign of what follows the x, what you're dividing by. So -5 goes on the outside. Yeah. Then you list all your coefficients. So this would be a 1. This would be a -4. And the last one would be the constant, which is 0. We need those to be in order, decreasing degree, and if any term is missing, we plug in a 0 to hold its place. Then you bring down the first term. So I bring down the 1. I multiply by -5, put it in the next column, add it, it's -9. Multiply it by -5, put it in the next column. I don't even need to add it because I completely ignore the remainder for for slant. What I take is what's left. As I move from the left, given the remainder is the last one, the next one's the constant, the next one gets the x. And because it's an equation, because it's a line, you put it in equation form. Y equals x minus 9. So that is your slant asymptote. Yep.
But why are we ignoring the 45?
Because you don't need the remainder when you're finding slant. Is it part of the divide, like the quotient? Yes. But when we find slant, you ignore the remainder. Yeah.
So can we just skip that part?
The last one.
Yeah.
Sure.
Putting the 0 at the end.
It won't always have a 0 at the end. But yeah, you can always skip the last one. All right, go to the next one. Again, look at your degree, top and bottom. The one on the top is one more than the bottom, so I know it does have a slant. In this case, we cannot use synthetic division. If it is not x plus or minus something to the first degree, then I can't use synthetic. So I take the numerator, 2x to the third minus 3x squared. There is no x term, so I add in a 0x plus 4. Divide it by, the divisor is x squared minus 4x minus 5. And then we do first into first. So what do I have to multiply x squared by to get to 2x to the third? 2x. And I multiply it times all three terms on the outside. So 2x times x squared is 2x to the third. 2x times negative 4x is negative 8x squared. 2x times negative 5 is negative 10x. Now this is taught two ways. One, subtract, okay? Or change your signs and add. I would recommend the change your signs and add because people make silly mistakes when they subtract negatives. So if I just change my signs and then add these, the first one should always cancel if you did it correctly. Then I get 5x squared plus 10x, bring down the 4. And then repeat that process. So what do I have to multiply x squared by to get to 5x squared? Positive 5, and multiply it times all three. So 5x squared minus 20x minus 25. And you could literally stop there. I would, if I was actually dividing it, I would change my signs. This would be my remainder. But all I need is my x term and my y-intercept. Once I get that, I literally ignore the remainder anyways. As long as these cancel out, you don't need the rest of it. So now this is y equals 2x plus 5. My first, oops. All right, example 5. Oh, go back. All right, this says use the graph to create a sign table. So in this sign table, it's going to give you values. So from negative infinity to negative 5, what's happening to my graph? From at negative 5, what's happening? From negative 5 to negative 2, what's happening? So it's going to divide it up into sections. And this is the sign graph. So is it positive? Is it increasing? Is it that kind of thing? Is it looking for here? So as I go from negative infinity to negative 5, my first cutoff point is at negative 5. So what's the sign, because that's what it says, right? Sign table. What's the sign of my y values from negative infinity up to negative 5? Are they positive or are they negative? Negative. And you could write neg, you could write minus. I don't care what you write. Just know what you mean, okay? What happens at negative 5? It's 0. Then negative 5 to negative 2. What's happening from negative 5 to negative 2? They're all positive. Then at negative 2, it's undefined. Oh, that says UND. Then from negative 2 to 5, negative. At 5, 0. And 5 to infinity, positive. So we will eventually use sign charts to understand the zeros of our graph, to understand what's above and below, that kind of thing. It might ask you to do this based on the equation itself, and in that way you are literally plugging in values from some points and others. So by the end of the rational functions, not only should you be able to identify all the different kinds of the asymptotes, the zeros, the domain will get into holes, but you should also have a general idea of what your graph looks like. And for that, sometimes that requires plugging in points. Like if I go back to the beginning of my graphs and all I had was my vertical asymptotes and a horizontal asymptote, let's say, and I don't know what's happening on the ends here, then there are going to be times in which you have to plug in points. I can plug in a point that is to the right of my vertical asymptote and see, is my graph above or below the x-axis? I can plug in a point to the left of my vertical asymptote and see, is my graph above or below the x-axis? So there are going to be times that you need to get more specific, especially on the AP style questions, about the actual size or look of your graph. Some you just need the asymptotes or the zeros or the domain, but some you need to describe the end behavior, okay? Or you need to describe the behavior of your graphs. Are they above the x-axis or below the x-axis, okay? Questions on vertical, zeros, or slant? Okay, yesterday I told you this was 4. This is the one I had you skip. So it says the rational function h is expressed as the quotient of two polynomial functions f and g by h of x equals f of x over g of x. So what that tells you is which one goes in the top, which one goes in the bottom. This guy is my numerator, 6x to the third minus x squared plus 60x minus 25 goes over the denominator, which is 2x minus 1. This is how your AP questions are going to be given to you for rational functions. It typically doesn't give it to you already in fraction form. It typically says this is true, and then it gives you the f of x and the g of x. So now it says if the graph of h has a slant asymptote. Oh, sorry, it says, that's not, I wrote the wrong thing. We don't know what this is. It says, if the graph of h has a slant asymptote of y equals 2x minus 1, which of the following describes g? So you have two options. You could literally like multiply it back out, okay? Because it's basically saying if I had 6x to the third minus x squared plus 60x minus 25, and I don't know what's out here, but at the top it would be 2x minus 1. I could reverse this process. Or you can look through your choices, and I would say it's a lot easier to do that. It says G has a degree with leading coefficient 3. G has a degree of 2. G has a degree of 3. G has a degree of 4. First of all, what has to be true for it to be a slant asymptote? What has to be the degree in the bottom? 1 less than the top. So what does the degree in the bottom have to be? 2. There, I ruled out 2 of these. Okay? The second part says the leading coefficient is 3. So this would be if this said 3x squared. Does that result in 2 being at the top? Yes. The other option would have been, if it was not 3, it would have been 12x squared. Would that have been a result of 2x in the top? No. So A would have been the correct answer there. Does that make sense? Okay. Okay, if you look at this, the exponents are this is the third, this is the fifth, so 2x to the fifth over 2x to the, 3x, sorry, 3x squared. The top is bigger than the bottom, so there is no horizontal asymptote, so this is the scenario in which you have to plug in your infinities. I'm going to cross through 2 of these, I'd get 2x to the third over 3, and then if I plug in a positive infinity, it's going to stay positive because we just cube it. If I plug in a negative infinity, it's going to stay negative. So as it increases without bound, the values increase without bound. As x decreases, it decreases without bound. Okay? A was the correct answer there. And then 6, the polynomial function p has 3 distinct zeros with a multiplicity of 1. So if I wrote it out, that would look something like this. I don't know if it's x plus or minus, but I know that there's 3 of them, and I know they're all different. Its leading coefficient is positive, so when I multiply that all the way out, I know it's an x to the third, and I know it's positive. It has exactly 1 0 with a multiplicity of 3, so that's my numerator. This is my p, which is the numerator. This is my q, which is the denominator. Okay? Q has 1 0 with a multiplicity of 3, and its leading coefficient is negative. Now I know it's a negative x to the third. The rational function can be written as p over q, which the following is true, and it would be that they're the same, which rules out this, and it rules out this, okay? And whatever this value is would be positive. Whatever this value is would be negative, which would make the quotient negative. And that's C. Questions? Okay, so For 8, 9, and 10, you'll see I'm not going to give you the AP Classroom questions. I wait until they get combined because a lot of them mention holes in 8 and 9, which makes no point. It's weird to me that they bring the holes in, but holes aren't taught till 110. So for 8 and 9, it's just 2 PDFs. For 10, it's just going to be a PDF. And then before we're going to review again, but not before your quiz. I'm going to save it before your test. And then you will go back and do the AP style questions for those, okay?